In this video, we are doing yet another question on limits and continuity. This is Maths and 5, and we are doing a past year paper from April 2022 or February. But it was written in 2022, April. This was the first paper of the year. If you're new to my channel, please care to like, share, comment, and subscribe. I do post BSc, BSS, and Maths and 5 to N6. Subscribe for more, and you're a returning viewer, please care to share, comment, like, and just continue helping the channel grow, and reach more students that need help. Okay, so I'm not going to do a lot of talking, just going to get straight to the point. If you want a proper introduction, click on the link in there on the corner there, because I did a proper intro on limits and continuity. I did mention that you need to know all your differential rules. We went over L'Hopital's rule, and we went over the 4 different cases that you face yourself with and what to do in each and every one of them. We also discussed what to do when you are being asked to prove whether or to find the values of x when a function is discontinuous. Okay, so however, we are going to do this question here, 1.2. We'll do it also with the first 2 questions. Okay, so guys, as you should know by now, that whenever you are doing these questions here, the first step that you need to take, for you to find the limit, you need to find whether it's indeterminate or if it's determinate. So we have 4 different cases when we have indeterminate cases, but we need to identify them. I went over how you can approach each and every different case. Okay, so this case here, we have lim. Okay, just allow me to shift for space. Okay, I'm just going to shift this for space. Okay, this is what we have. Right. For this case here, we have lim x approaches infinity. Okay, x approaches infinity, and I'm just going to rewrite it. I know you can see that we have x, and you can see that we are multiplying this with sine 7 over x. Okay, by the way I can see this, we are going to have infinity times 0, right? This is the indeterminate form. How do I know that? Well, if I'm going to substitute the x with the infinity, this position here would be infinity. Remember, we only have 4 cases, so this is the case that we are facing when we have infinity. Okay, also, how did I know that this is going to be 0? Sine 7 over x is going to be 0. Guys, I mentioned that it is very important that you know, we would see, dividing with a very large number is equal to 0. So this would be 7 over infinity, right? 7 over x is 7 over infinity. And imagine dividing 7 with 100, right? And then you divide 7 with 1,000. You will notice that your answer gets smaller, right? The more zeros that you get before you get a number, the smaller the answer is getting. So basically, that is what we call, I'm forgetting the word, but it is I forgot the word, but yeah, it is that the number that is being approached, like it's getting smaller, right? When I think of it, I'll mention it later on. Okay, so that's how we know that this is 0. Now we need to write this in a fractional form. It's either we're writing it like this, so we can use L'Hopital's rule, or we're going to write it like this. Okay, so let me tell you, remember, dividing with a smaller number, multiplying with a big number is equivalent to dividing with a small number. Okay, I'll think of the word that I wanted to mention. Okay, but even without that word, you can understand, right? You can understand what I'm saying. So we can see that we have sine 7 over x, and then we have x over here. It's very tricky for us to find out what is this equal to, because it's already 0. So my advice to you guys is that whichever one that is equal to 0, it's best you leave it in the numerator. Okay, and then the one that is equal to infinity, the one that is showing infinity, which is x, that one there you can manipulate, right? Because remember, we are multiplying here with infinity. Infinity is a very big number. So multiplying by a very big number is the same as dividing by a very small number. So we need to make this very small, right? We need to make it very small. So infinity will be the same as us saying 1 over, multiplying by infinity will be the same as us saying divide by 1 over infinity. By 1 over x, right? When you divide by this, okay, when you divide sine 7 over x by 1 over x, remember 1 over infinity, right? 1 over infinity is a very, very small number, right? 1 over infinity is a very small number. So back to the statement, multiplying by a big number is the same as dividing by a small number. So you were multiplying by infinity. So what do you need to do now? You need to divide by a very small number, and 1 over infinity is a very small number, because imagine 1 over 10 will give you 0.1, right? But now if you say 1 over 100 or 1,000, it becomes very, very small. Now imagine if that is infinity, it becomes very, very, very small, right? So that is what I'm saying. Multiplying by a very big number is the same as dividing by a very small number. Okay, so by dividing sine 7 over x by 1 over x, 1 over x is almost the same as saying 0, but that is very small. Okay, so let's do that. So lim x approaches infinity. Okay, x approaches infinity, and then we're going to say sine. Okay, right, just a moment. We're going to say sine 7 over x, but then we have to divide this by 1 over x. Remember, dividing by a very small number is the same as multiplying by a very big number. So guys, this itself is 1 over infinity, which is equal to 0. Why did we do that? Because when you're finding out that when you substitute, look at this, when you substitute x into this here, the indeterminate form becomes 0 over, this numerator becomes 0 and the denominator becomes 0 because you're dividing by a very big number, so it is 0. Now, when we're here, we use L'Hopital's rule, and what does it say? It says that for you to find the limits, when you can't, then you derive the numerator and the denominator. Okay, we're going to do that. I mentioned that it's important for you to know your derivatives, because not for everything you need to go to your formula sheet to check. So limit approaches 0. We're going to derive the numerator, right? We shouldn't be hard. Sine, the derivative of sine, you guys should know that is cos, right? It is cos, but we'll say cos 7 over x, and then we need to find the derivative of 7 over x, right? 7 over x, guys, is the same as saying 7 times x to the 1, right? So we need to derive that as well. You should know this from N4. Okay, so this was going to be minus 7x to the minus 2. That's correct. And then we're going to divide this by, you know that 1 over x is the same as saying x to the minus 1. The derivative of this using the power rule is going to be minus x to the minus 2. Right. So, when you reach the stage, you might even panic and say, if I substitute sine over here, if I substitute x, infinity over here and over here, it already means that the top itself is infinity over infinity, because if you put infinity, it's negative. It's going to be negative, infinity, negative, right? You're thinking about deriving again. You will look there and you see that it's 4 marks. So I don't think it's going to, okay, N5 maths is deceiving. You can do a lot of work just for 2 marks. So let me take that statement I was about to say back. Right, so you just have to look at it, analyze it, terrorize that thing. Okay, so look at this. You have minus 7 times x, but then it's to the minus 2, right? That's where the thing is. And then you have minus x squared, minus x to the minus 2. And remember, you are multiplying. Don't be deceived by this negative sign. This negative sign is attached to the 7 and x to the minus 2. So the numerator, you're multiplying everything. The denominator is just there. So look at this. If you factor out, you can factor out x to the minus 2, but let's just take it with a negative sign, which is this, because we can even take the negative sign here and we'll have positive 7. Okay, so I'm going to cancel it like this. I'm going to take this and then take this negative sign with this. Okay, I'm going to take it like this, and I'm going to cancel them. Okay, we're going to cancel them. And what do we have left? If we do so, we are going to have, okay, let me just erase this real quick. I think it's kind of it's gonna mess this. I don't need this every time. Okay, so now we're going to have lim. How did we get the black one? Okay, yeah, now we're going to have lim aibo. Okay, now we're going to have lim x approaches infinity. What's happening now? We have cos, right? 7 over x. We have to divide this by nothing. But then we have the 7 over here, which is left. So we're multiplying this with 7. Okay, so just let me write this properly, because this is what we have. We have cos 7 over x. What are we doing with that? We are multiplying it with 7. Okay, now, okay, we should have written L'Hopital's rule here. I'm just going to write LH. So what happens now? We do our best and substitute and see what happens. I think at this stage we can already see that this might just be the answer. But now let's just check out. If we substitute, if you put x in this position here, it's saying 7 over infinity. Sorry, if you put infinity in the position of x, it's going to be 7 over infinity. And guys, this is equivalent to 0 because it's a very, very tiny number. Okay, so cos 0. Okay, so now let's just say is equal to cos 0, because we said this is close to 0 times 7. Cos 0, guys, you should know that it is equal to 1. Therefore, lim x approaches infinity would be equal to 7. Right? The answer for this question would be 7. That is how you earn yourself a smart 4 marks. Seems very complicated. I would agree to a certain extent because of this case, the infinity times 0 case. That's the most interesting case. But the rest is should be, cruising. Okay, I know it's maths and it can be hard sometimes, right? Okay, so moving on. The following question is asking us to, okay, it's another limit. So just allow me to erase this one here. It's another limit. Okay, the sky is the limit. You can, go as high as you want. Okay, this is like some motivation or something. Okay, yeah, for someone who really needs that the sky is your only limit. Even if you can look at those numbers that we're dealing with numbers that they are so big, we can just equate them to 0. Okay, or close to that. Okay, so the following question is a limit as well. It's a 3-mark question. They want us to do what? They want us to find the limit. Okay, let me just rewrite that. They're saying that lim. Okay, what have we got? We've got limit x approaches minus 3. Interesting. 3 to the e 3e 2x plus 6, and then we're saying plus x squared minus 12. We are dividing all this, guys, with x cubed plus 6x squared plus 9x. The first thing that we can do is to find whether it's indeterminate or not. Okay, so if we put minus 3 over here, we're going to have x to the power of, e to the power of 0, because it's going to be minus 6 and 6. So it's going to be 3e to the power of 0, which is going to be 3. And then we're going to say plus. If we put 3 in here, it's going to be plus 9, because it's a negative 3 and you're going to square that, it's going to be plus 9. Right, 3 plus 9 is going to be 12 minus 12, that top is going to be equal to 0. So you should be doing it like that, guys, to find out the indeterminate form. So it's going to be 0 over the denominator. You don't have to assume. You can just punch everything in your calculator. This here is going to be, 3 times 3 times 3, 27. So if this is 27, and then if this is 6 times 9, which is going to be 54. And then you're going to have plus 9, okay, minus 27, because you have 3. Not really. Actually, yeah, 9, 18, 27. So you're going to have minus, wait a minute, minus 27. Okay, my mistake is here. If you put a minus 3 here, and then you cube this, your answer should be minus, ne? Exactly. Yep. And so we have minus 27 minus 27, both are equal to, if you add them, you get 54, 50 minus. Yeah, guys, the denominator cancels. What you can just do is punch everything in your calculator and find out. So this is the indeterminate form. Automatically, we know that we need to use L'Hopital. So LH, or is it L'Hopital? Not quite sure. But the pronunciation doesn't matter as long as you know what you're doing, right? Unless you want to be a lecturer or something, then yeah. So we have lim x approaches 0. What are we going to do now? We're going to find the derivative of the numerator and the derivative of the denominator. So we're going to derive the numerator and the denominator. Okay, cool. So the what I like about E is that you just spit out the derivative as it is. You just spit it out as it is if you're deriving it. We're going to have 2x plus 6, but then we need to multiply this with the derivative of the exponent, this expression in the exponent, right, which is 2. So we're going to say times 2. Okay, and we'll say plus 2x, the 12 gets cancelled out, and then we're going to say 3x squared plus 12x plus 9. And then over here, you have to do that again, substitute again. This is going to give us 3 times 2. Guys, I'm saying 2 times minus 3, and then the top will give us 0, and then E will be equal to 1. It will be E to the 0, and we have 1. And then if we multiply that by 3, we're going to have 3 times 2 is going to be 6. And then here is going to be minus 6. So the top again is giving us 0 over 0. How about the denominator? Pretty think that it's going to be the same thing. This is going to be minus 12. And then this is going to give you 3 times, okay, just punch it in the calculator and you will find out that the denominator is also equal to 0. Okay, now again we need to find the derivative again. So lim x approaches minus 3. What do we get this time? Again, we're going to have E is going to come out as it is, but now remember, this is 2 and this is 3, so it becomes 6. So you're going to say 6 to the E, 6e, 2x minus plus 6. We need the derivative of this, right? I mean, we already derived it because it's e. Now the derivative again is going to be times 2 here plus 2. Okay, and then we divide by 6x plus 12. Okay, and we need to find if it's going to cancel out or not. By the looks of it, I doubt that it would cancel out because we're going to have 6 times 2, which is going to be equal to 12. Okay, so, and the denominator as well is going to be minus 18 plus 12. Okay, so now we can substitute. So therefore, we can say lim x approaches minus 3, let's just say is equal to, the top here is going to be 6 times 12. We've already been repeating the E story for a while now, so we know that the top is going to be 12, right, plus 2, and we're going to divide this, really, sorry, yeah, 12 plus 2, right, so we have to say 6 minus x. 6 times minus 3, guys, that gives you minus 18, and then we're going to have minus 6. Okay, and another way of writing this, we have 14 over minus 6, so that is 7 minus 7 over 3, minus 7 over 3. And guys, if you are doing this, you do it faster, and that's how your answer would look like. Okay, so that's how you also get yourself 3 marks. Not saying it's easy, but it's doable. Okay, so just continue practicing. Okay, this is like an icebreaker, you know, for the entire paper, because you get a lot of interesting derivatives and integration. Okay, the next question. This is the proving whether it's to find the x values where a function is discontinuous or continuous. Guys, for this one, yeah, you just have to make the denominator equal to 0. That's the only thing that you do, and you solve for x. So you're gonna, in any case that you get, so we're gonna say 3x squared plus 2x minus 8 is equal to 0. So what we do, we find the we factorize it. Okay, so 3x, a lot of you guys should know this from high school, okay, or even before this, n4. Okay, so we're gonna have x here, and then we're gonna have 0, right? So we need to, guys, I'm not gonna teach you how to do this. We need to find out the multiples of x of 8. Is going to be -4 times 2, or we can have 8 times 1, or this minus could be here, we don't know, right? But then by the looks of it, the term in the middle has to be positive. So if we put 4 over here, we're going to have 4 times 3, which is going to give us 12. And then here we're going to have 1. Okay, sorry, we're going to have 2. We're going to have 2 here. And then 2 times this, whether you add them 2 times, so this is x, 2 times x, whether you add that or not, is never going to be equal to positive 2. So the 4 is in the wrong place. We have to put the 4 here, and then the 2 here. Now, if we say 2 times 3, we're going to get 3x, sorry, 6. Hey, and I have 6x. Okay, and then 4 times x is going to be 4. So which one has to come with the negative sign? Well, it is the 4. So we're going to have minus here, and we're going to have plus here, because this is going to give us 6x. All right, just like that, you have factorized it. But that is not the answer. You remember? That's not the answer. So we're going to say x is equal to 4 over 3. You know how to take this out. Or x is equal to -2. And then it's very important for you to substitute these x values, into that. Okay, you substitute each x value one at a time. If you put this here, right, or you put it here, you put them both there. No, okay, you don't put them both. You put the 4 over 3 over here, and then you put the 4 over 3 over there. Find out if it's equal to 0. If it is, then this x value is confirmed. And then you do the same with this one. If it is, then this x value is also confirmed. I did that, and both x values are the answers, and that's why the question is giving us 2 marks. Okay, guys, that is how you get yourself 9% of your paper. I mean, if you are in 2022. Okay, if you enjoyed this lesson, please care to comment, like, share, subscribe, and help a lot of other students that don't have, you know, the resources, or, you know, the tutors that, not tutors, lecturers. Okay, thank you guys for watching. Until we meet again in the next video. Cheers.